2018 implementation to ensure healthier and safer workplace lead to a safer planet. Another is data collection on safety, health, environment, and process data that should be collected. Accident statistics have to be collected, work environment data also collected and to be reviewed for taking necessary corrective action. That is PDCA cycle. These are the challenges we have to face, and the role of global collaborations. And the here role of global collaborations, no single organizations or nation can address these challenges in isolation. The beauty of this conference lies in its spirit of collaborations. By sharing knowledge, experience, and innovations practices, we strengthen our collective ability to overcome obstacles. As a professional, we must establish international standards that are adaptable to local context, ensuring consistency while addressing specific needs. Partnership between government, industries, and academia will also play a pivotal role in driving progress. Now, what actions we have to take? The call of actions. Let this conference be a starting point for actions. As we engage in discussions and think about the solution that can be implemented immediately within your organizations and communities. Remember, every small step contributes to a larger movement towards safer and more sustainable workplace. Let us work towards reducing workplace injuries and fatalities to the absolute minimum, creating environments where employees feel valued and protected, building workplaces that are resilient to future challenges and aligned with the global sustainability goal. Following tools will also help to make the workplace safer. Conduct safety audit, electrical audit, fire audit, energy audit, preparation of ESSR, CSR audit, and ESG BRSR report, and to submit the concerned authority. Ensuring sustainable cadential ensuring suitable cadential machineries to recognize institutes relating to HSE, and encouraging to implement suitable management system related to HSE, special focus on notifiable diseases. In conclusion, I will like to leave you with the thought that safety is not just a policy, it is a value added and responsibility. It is our collective duty to ensure that every worker return home safely at the end of the day. I am confident that the insights shared during this conference will spark transformative ideas and actions. Together, we can lead the way to a future where workplaces are not only safer and healthier, but also more sustainable, inclusive, clean. Thank you once again to all of you, especially Professor Dr. R.N. Jana, for the opportunity to share my thoughts. I wish all the best of your success in the near future. Thank you so much.
Thank you so much, sir, for your valuable insight. Next, our chief guest, Shri Shat.
ঠিক আছে। এইরকম করে একটু করুন। ঠিক আছে। হ্যাঁ পেয়েছি। এই লোকেশ 1 মিনিট বইটাকে একটু দেখো, সকলে মিলে করুন। সঠিক দা রিড হবে।
Thank you, all of you. Now I would love to request Dr. Robindranath Jana, who did his PhD from IIT Kharagpur, is presently an associate professor, Department of Chemical Institute of Technology, HIT. He has about 25 years of teaching and research experience. He did his postdoc from Artificial Muscle Research Center, Konkuk University, Seoul, South Korea. He worked as deputy manager, Haldia Petrochemicals Limited, Haldia, India, deputy manager, Tough Seals Private Limited, Jamshedpur, India, and as polymer technologists, Bharat Plastics, Daman, India. He received the National Awards for Technology Innovation 2014, Ministry of Chemical and Fertilizer, Government of India. He was an associate editor of the Science Jet Journal of Cognizer, publishers and review editor of Frontiers in Polymer Chemistry Journal. He has published more than 40 research papers in reputed international journals and more than 80 conference papers. I would like to request him to come up on the stage for the publication of his book named Fundamentals of Safety, Health and Environmental Management.
I would like to say a few words about my book. The title of this book is Fundamentals of Safety, Health and Environmental Management. This book contains about 10 chapters, and the motive of this book is like that. The book Fundamental of Safety, Health and Environment Management provides a comprehensive introduction to the essential principles and practices needed to establish and maintain safe, healthy, and environmentally sound workplaces. With the rapid evolution of industries and with increasing complexity of regulatory requirements, the need of robust safety, health, and environmental management is never been more critical. This book is designed to equip students, professionals, and organizational leaders with the fundamental knowledge necessary to address these challenges effectively. The content of this book covers a wide range of topics within the HSE statement, starting with fundamental principles of workplace safety, moving into occupational health strategies, environmental management systems, and regulatory framework. Each chapter is structured to build a solid understanding of both theoretical concept and practical application, enabling readers to not only comprehend the intricacies of HSE practices, but also to implement them within various organization contexts. For this publication, I owe special gratitude to my wife, Tanushri Jana, my daughter, Titas, and my son, Rajdeep, for their constant encouragement and support. My daughter, Titas, a PhD scholar of the Department of Design, Vellore Institute of Technology, VIT University, Vellore, has played a crucial role by conceptualizing and designing all the illustrations, drawings, and schematic diagrams in this book. My sincere thanks to all the teachers, colleagues, friends who have directly and indirectly have supported and motivated me throughout this journey. I also appreciate the educational, editorial, and production team of White Falcon Publishing for their invaluable cooperations. I finally honored to express my gratitude to the chairman, principal, dean, HOD of Haldia Institute of Technology, as well as other leaders of their institution for granting me access to their libraries, facilities, which generally aided the preparation of this book. This book will be available within a week in Amazon and Flipkart as usual. So I think this book will be helpful to the student who are studying ADS, that is Advanced Diploma in Industrial Safety, and it is as per the course curriculum design. It is that IS 102, that subject code presently, whatever we are teaching here. The student of our institute as well as the other student from other institute of this course will definitely be benefited. As you know, in India, there is very less number of the books available on fire and safety engineering. Our the Professor B.M. Shen has written so many of books on fire safety. There is very scarcely number of the books on safety itself. So we are trying to develop, and in near future, I think the people who have the expertise, they may go through the book, and if there is some correction, modification is required, it is welcome, and that book will be enriched later on. The edition may be revised, and with this, I would like to thank you once again.
Thank you, sir. Now, I would like to request Sri Sanjeev Kumar Jana, Joint Convener HSE 2024, Head EHS, EIVL Dhunseri Petrochem Industries Private Limited, Haldia, to share some insights of our program.
Good afternoon. I'm very thankful and very honored to come here and join here. The theme is workplace with better HSE. All the industries taken care about the health, safety, environment taken. But why accident still happen And some industries, they are not given so many importance on this. And what is the background of this? First we come 90s or 80s. That time it is just a regulatory, a safety department or environment department. But nowadays you can see it is focusing all the industry head or top management. Because now industries understand the importance of safety, health and environment. Because the direct cost and indirect cost, that is seen that a accident happened or a mishap for environmental, any legal point it comes, it makes a great loss. So, nowadays, all the industries head, they come for the top management, they think for the safety is a core values. Core values. What is core values and why they core values? Because they now focus, they seen that the only safety officer, when we are in a safety officer joining in industry, first I go Mitsubishi, that is a very good organizer. But later on I see that the industries, they are mainly focus safety for the legal part only. They are required a safety officer as it is tested in the Factory Act and rules. Safety officer, there are thousands of people are there working, but only one safety officer. How can they maintain the safety? They are only, any accident happen, it is the responsibility of safety officers. But now, it is proved that the safety is a line manager's job. If we not find the safety, all the department not given importance, then it is a fail. Then it is just like written as safety, health and environment. They are giving the importance, but not importance. When the Japanese in Mitsubishi, they always told the safety line manager's job, and also safety is in your DNA or culture. Either it may not be great extent. Now, you can see last 2-3 years, ESG, environment, social governance has come. And now, all the plant, they have to submit the report of health, safety, environment report in the international stage. So there is no hide work not going. So we have to, for what we have done, that's shown in the ESG report. So for better, here all the speakers come from the institute or some engineers and some senior persons are here. We have learned that what to be do, they have all the industries, all the person knows. But what is required? The management is required. In this book, it is written as, it is a study book. Study books, they are given that health, safety, environment. But here it is term use, health, safety, environment, management. All the rules, regulations, policy, JSA, all the is in place in industry. But the management part is not there. So, from this book, we have learned that how to manage the situation, how to manage the accident, that is required. And this book, whenever I have studies in safety, health, environment, that environment books is there. but safety books is very not available that time. Even now, good safety books is not there. Only the safety students, they only study by the Xerox copy and others. This book will be very helpful to the teachers and industry people as well as the students. That is a very, very good books. Already I have seen that. And the manager for the workplace better safety, we need what do we need? We have to give the line managers responsibility, and safety comes in the DNA of the every employees. Okay, then and proper safety, health safety and management is required. Either safety is for in place only for the in the bookish word, or it is in the for overall. But for the good safety management or betterment, it is required the culture, safety culture, and also it comes from the DNA. Thank you. Hope for the best for the conference. Thank you. And this type of conference will help the student, industry people, as well as the institute.
Thank you so much, sir, for sharing a lovely insight with us. Now we would like to felicitate Mrs. Usha Dhara, organizing member HSE 2024. To come up on the stage and take the badge, memento and bouquet. Now we would like to felicitate Mrs. Shuniti Giri, organizing member of HSE 2024, with flower bouquet, batches and memento. Thank you. Now we would like to welcome Mrs. Moitri Das for the felicitation, organizing committee member HSE 2024, with bouquet, batches and memento. Thank you. Now we would like to welcome Mr. Torun Kanti Hajra on the stage for the felicitation. Organizing member, HSE 2024. Thank you, sir. Now we would like to welcome Mr. Shubroto Bhomik on the stage for the felicitation. Organizing member, HSE 2024. Thank you everyone for being presenting here, and we will move on to the technical round. Before that, we'll go to high tea. Okay. Then we'll come back we'll go for a high tea and we'll come back here to start the technical round. Thank you.
এই তো ঠিক আছে চেক চেক
हेलो हेलो हेलो
বলবেন তো ফেলিসিটেট প্রোগ্রাম হ্যাঁ
हेलो 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 So, good morning everybody.
লাইটগুলো অফ
Now we are going to start our plenary lectures. So before that, we have already completed our inaugural session. So before going to start plenary lecture, we are now going to felicitate Mr. Dilip Kumar Bera, Chief Patron, Health Safety and Environment 2004, as well as President Haldia Brajalalchak Welfare Organization. I am requesting Mrs. Tanushree Jana, Principal of Institute of Fire and Safety Engineering, to felicitate Mr. Dilip Kumar Bera.
সেকেন্ড টাইম
Thank you, sir. Now we are going to start plenary lecture, and this lecture will be given by Sri Samol Ranjan Maiti, HSC Guide, accredited HAJOP leader, ex-ICI Rishra. Mr. Maiti, please.
Thank you. First of all, welcome to my lecture. Please listen carefully. Okay. You see, save your people at workplace and surrounding by cost assessment. Actually, first of all, let me tell my students cost. That is control of substance hazardous to health. Control of substance hazardous to health. Is there any non-hazardous matter? My students, please, can you tell? Is there anything non-hazardous to health? Anything non-hazardous to health? We'll take little time to just discuss interaction, then I'll go for lecture. Is there anything non-hazardous? You may say, can you tell anyone? Students. Huh? Students. Please. Hello. Please. React. Is there anything non-hazardous? Anything non-hazardous? Can you just name at least one name? Medicine, milk, fruit, water. Huh? Yes? Anything? Just loudly tell. Huh? Huh? Okay. Thank you. Actually, nothing is non-hazardous. Okay, if you say water, there is also hazardous, because hazard depend on its property, its quality, quantity and application, right? Because so if water is hazardous, then everything is hazardous. Okay. So first of all, this concept came from ICI, this cost assessment. ICI, Imperial Chemical Industry. They are the pioneer of all safety studies, all safety matters, hazard study. Today morning someone was telling about the pressure cooker accident. I told my students during my class that let us do the hazard study of pressure cooker. Forget it. Okay, this control of substance hazardous to health. First of all, from learning incident, we want to say something. Okay, there, in Dasnagar, Howrah, there is a bonded godown by Central Excise. So they were keeping the materials, different type of chemicals, then silk cloth, so many things, all seized. So what happened, one day there was a fire. So people were knowing that so many things are kept there, so they went for looting. They went for looting all these materials, but there was one perfume drums also. And that perfume was derivatives of aniline. Those who are acquainted with the aniline, so they know that it is very hazardous. It's vapor, cause chemical asphyxia. Okay, so what happened? People were dying. So we were called, we were informed. So our doctor with our safety department team, we went to that place, and then with oxygen and methylene blue antidote injection, we tried to, I think one of my students is also here. He was in fire department. We have several times narrated this when Mr. C. Mahadevan was there. One student is there. Yes. He was in ICI, so he is also knowing this fact. So, this is because of awareness. Because those who have seized those, they didn't know what are the chemicals, what are their properties. Okay. So that's why this cost assessment is very much important. It happens, so many people, those who are having money, okay, let us just invest in a cold storage. In cold storage, ammonia being used as a refrigerant, isn't it? Ammonia. So what happened, there are a series of accidents because the owner of the cold storage, he doesn't have awareness, isn't it? I was insisting in the beginning also, when the introductory lecture, that this awareness is very much required from grassroots level, from school, then to industry or entrepreneur. Just before a few days, one person of Haldia was telling me, we want to just make one aquatica, like Calcutta, it is there. So he want to make one aquatica. I told, okay, you make it, you invest money, you have place, but what happened, you require a lot of chlorine, so know the hazards of chlorine, and then you go for. Okay, so that's why this control of substance hazardous to health is so important. What happened in this case, this ammonia, the owner is not knowing, the people who are not knowing, those who are operating, they were not knowing. So what happened, when these accidents happened, ammonia exploded and the whole wall was collapsed. Okay, and we just asked them, and what did Pollution Control Board did? They make immediately one rule. They make ammonia should be abolished and some other chemical should be introduced as a refrigerant. Is it possible? Malik just escaped. The owner escaped. He was absconding and no case could be developed. So what happened? Still now I think ammonia is continuing as cold storage refrigerant. So this incident gave us a lesson that ammonia hazards should be controlled. How? I went to that ammonia user and told one big company, how you are just identifying the leakage of ammonia. Then they told that we are burning sulfur and just going, taking to the leakage place and identifying. And you see, you are doing a very wrong thing. First of all, sulfur, you cannot keep much. I think beyond 2 kg, you require Arms Act license from DM. And also, sulfur produces the sulfur dioxide, which is toxic. So, and ammonia is flammable. They don't know. Ammonia is flammable also. So what happened, then they told that how will you identify the leakage point? It was simple. Hydrochloric acid, just wrap on a piece of cloth, on a stick, and then go near to that. Ammonium chloride will be formed, and that is good for health, that is not bad. So you can identify. So this control of substance hazardous to health is very, very important. You see, this I have given this data. Ammonia is explosive. There is upper explosive limit and lower explosive limit. So within that range, if ammonia there remains, ammonia storage particularly, this is locked. Okay, so there is leakage and there is an explosive mixture, and when they go for some repairing job, it caught fire and explode. Okay, so that's why. And another case is chlorine. You see, chlorine, that is also used in many places for, okay? Okay. Ammonia, this chlorine leakage. So in the water pool or swimming pool, aquatica, everywhere this chemical is used for, even those who are water purification, say municipalities, they have the water treatment plant. In Risra there is a water wash, so that comes under major accident hazard unit, because they use more than 10 tons chlorine. So you see, chlorine is very, very dangerous, and they don't know much about the chlorine, how to stop it. So we trained them about the chlorine incident, and my students know very well that how to combat the chlorine leakage incident, and we are doing also mock drills, how to tackle the chlorine leakage. So that's why, this before coming to my topics, I want to give the learning from learning incidents. So this chlorine travels like that. This chlorine consequence analysis we did in Risra, and also there are nowadays softwares are available. And you see this another figure I have seen, that how Bhopal was victimized. Okay, so Bhopal gas travels how? Okay, that MIC gas, methyl isocyanate, that is used in, this car painting also. We had a booth for this painting system. So there also methyl isocyanate is used. So this consequence analysis is very much necessary for this control of hazardous chemicals to health. I have already told that everything is hazardous, okay? Because hazard depend on the, yes, if you want, we can share the slides, no problem, you can take it. So hazard depends on these 4 things. And then after the hazard, after assessment of hazard, how much risk you can take, okay? Incident, accident, near miss, disaster, on-site, off-site emergency, and closure of the industry. So we don't want that. So that's why the rules are being made, rules are being implemented as much as possible. But actually people take risk, isn't it? Everybody take risk, because no risk, no gain, right? But high risk, high gain. No. What happened? High risk, high pain, right? So you see how to mitigate those hazards? Identify, evaluate, eliminate, isolate, protect. If it is not done, then escape, okay? So that is the major accident hazard evaluation, on-site, off-site emergency plan, and that figure you see, assembly point, okay? And there is one wind shock. Wind shock because of, to see the wind direction. Where will you go? You may say immediately, where will you go? According to the wind direction? Okay? Opposite? No. Huh? If you go opposite or if you go wind direction, towards the wind direction, you may go to the source. So you have to go to the left or right, right? So then you can be away. In Bhopal, it happened like that. People were just going to the source because they are going opposite to the wind direction. And that's why so many people just killed. Okay, so hazardous chemicals are classified by UN, 9 classes. So, but everything is hazardous, I told you, keep in mind. So, all are classified, but what happened, you know, this particular thing, I always insist to all the industries, whether you submit quarterly return or not. This quarterly return means you can identify which are the hazardous chemicals. There are about 700 chemicals in the list, okay, given in the rule, manufacture, import, storage of hazardous chemical rules. But and quarterly return, if these chemicals are there, you have to mention the quantity and you have to give to the government. Most of the industries do not care about this because it is to be given to Pollution Control Board and Factory Directorate, but they don't care much. So even some industries, they give lot of chemicals which have no meaning, but according to the list, you have to give the list. Okay? So this Form 23A, this is very, very important for those who are safety professional. Whenever you go to industry, first of all you see that whether it is being given or not. Anyway, but beyond that list also, there are several hazards. Dust hazards, I have seen in the carpentry, dust hazards are there. In the blasting, sand blasting, where there is the epoxy resins are being, okay, glass wool lining is being done. And obnoxious gas. You know, people, you see, I went to one industry, he was holding in one hand and just doing the welding. And he told how I will just use the shield or nose mask. I told that it is available. Helmet with shield and the mask. Why don't you ask for that? So, these type of things should be avoided, okay. Everything is hazardous, so control of hazardous substance is at home also is required, isn't it? That's why I told in the beginning, introductory lecture, off the job and on the job safety, both are required. So control of substance hazardous to health is to be implemented even at home. Madams are using nail polish, that is also hazardous, flammable. Their hair remover also. You know this what that saver, aftershave lotion, aftershave lotion, perfume. Then this heat, that cockroach heat. These are, everything is hazardous. And of course the gas cylinder. People are telling in the introductory lecture that gas cylinder safety. You know, we always insist that use better long stick matchstick instead of the piezoelectric that lighter. Okay, we don't insist because you know piezoelectric lighter can be missed. You know, if you 2-3 times missed, then there will be accumulation of gas, and there will be, when you will burn, ignite, then there will be some explosion. Okay, so that's why this control to this controlling substance should be starting from home to industry. Okay, so you see, cause is a very multi-tasking matter. Okay, several things are necessary. This is not a particular focusing can be done. As I told, identify, evaluate, protect, like that. Okay, so it is given in the book also, that introductory synopsis, this one. So I don't want to take much of time for this. Okay, so confusion, you know, this hazardous and dangerous substance. There are confusions because, you know, particularly in the industry, if we say what is hazardous substance, then we have to go for that manufacture, imports, storage of hazardous chemical rules. And if it is a dangerous substance, that is the consequence. Okay, hazard is the cause and danger is the effect. So by that you can distinguish. Okay, what is hazardous substance and what is dangerous substance. So there are sometimes confusion. Okay, so what we have to see, acute toxicity, non-toxic but offensive odor. You know, this in LPG cylinders, you know, you get some offensive smell when some leakage is there. You know, that chemical is thiol or mercaptan is in ppm level it is used. You know, this small container of mercaptan, if it is poured here, whole area will be evacuated because of the offensive smell. In ICI, for our chemical manufacturing, we are using tons of those thiols. You know, it happens one time, you might be remembering, once it happened, the vacuum broken and then thiol came out, okay, from the tap. Yes?
One question. Sir, mercaptan gas mix the LPG cylinder in percentage of?
That ppm level, part per million. See, very little it is given. And it is not toxic, it is having offensive smell only. What happened? That leakage caused, even after Ganges, beyond the Ganges, people are complaining that we are getting offensive smell. So what happened like that? Okay. So you see, these things should be carefully studied first. Okay, before going to control of substance hazardous chemicals. Okay. Then this carcinogenic, some chemicals we don't get effect immediately, but if it is if we go to health, then there will be carcinogenic effect. Benzene is like that. There are several chemicals are there. Okay. Entry points, that inhalation, ingestion, injection and absorption. Injection means not injecting forcefully, but it is by cut or some injuries. Okay. So these entry points should be protected. By what? By mechanical method, by several methods are there. And personal protective equipment, PP is the last weapon. We always say in ICI that it is the last weapon. Because personal protective equipment, you know, people, if you use in the industry, they feel discomfort. If you give one helmet, they will say after that sometime you will open. If you give one mask, oh, I am discomfort. Even during the corona pandemic, we have seen that people are not using the mask because they explain many times that there will be carbon dioxide decomposition and there will be toxic effect, so don't use mask, better inhale. No. So this PP is the last weapon, we always say. If you give one spectacles, they say, oh, I am feeling discomfort. Okay, so that's why we say this is the last. So other things, you know, there are some definitions are there. So this definition, I don't want to take much of time. Okay, so what is called toxic, what is like that. So definition, this is important. LD50 and LC50, the lethal dose and lethal concentration. These are important for a chemical. Then, so management measure, there are different type of measures are there to control substance hazardous to health. So there are many things to be considered one by one. Okay. So these steps are very much important, and we say PP is the last weapon to mitigate hazards. Okay. So, and another thing, every chemicals has got this material safety data sheet, MSDS. So there everything is mentioned there, but we mostly don't follow. That's why I am insisting on the, particularly the cold storages. People don't have awareness regarding the hazards. So they could have read. After that, after visiting some units, we introduced there in Bengali local language the subtract of this MSDS and warning that if it is leaked, then if you feel ammonia is leaking, what to do, what not to do. So MSDS one thing, and these are the hazards, this what is called threshold limit value, TLV, threshold limit value are there. There are TWA, stale and C, these things are there, people might be knowing. Time weighted average values, stale, short time exposure limit, and C means ceiling. So there you see chlorine and ammonia being widely used in many places. I told cold storage everywhere, and chlorine for water treatment. So chlorine, if it 1000 ppm leaks, I have shown you the consequence analysis. So how it travels. Chlorine is heavier gas. If chlorine leaks somewhere, if you go to the top, then you are safe. If does not, then go left or right to the wind direction and just keep one wet cloth on the mouth. Okay. And for ammonia also same thing, but ammonia is lighter. So if you put wet cloth on nose and escape to right or left of the wind direction, you will be saved. Because these are nowadays common. Industry developed, then housing developed. First of all, industry is located in a very isolated place. Just like in 1939, ICA made one in the Pan Boroj area, one just small unit. And after that, the city developed, okay, the locality developed. So that's why this control of substance hazardous to hazardous to health is very, very important. Okay. So what to do? So decide, then think what are the chemicals I am using, then all these workers who are exposed to that, you have to study. Okay. So for that, there are two things are there. Hygiene monitoring to be done at workplace and health assessment program to be established. My learned friends were telling the management should be aware, the owner should be aware. That's why the occupier concept came after the Bhopal incident. That I don't know who are you or who is the owner. I want to give the name of one occupier whom I can catch. So that's why that occupier must be aware of that fact, and he should be able to consider those things. Okay. So cost, employer responsibilities and employee responsibility both are there. There are two things are there. I told happy and hyphy. High health assessment performance index and hygiene performance index, happy and hyphy. These are to be considered. And people who are exposed to all these hazardous chemicals, those are to be assessed. You see, there are statistical control. There are statistical controls are there. Okay. There are statistical controls are there. So how many people are exposed, how many samples are to be taken, and their assessment to be done. Most of the industries, hygiene monitoring, they do not consider about this thing. Dust exposure, they don't consider. And display at workplace. Display to be done, MSDS extract, and if possible, this SIRE code, SIRE, that is by color code and giving a number, you can identify. Just like our NFPA, those who are aware of that, NFPA codes are there, toxic, flammable, okay, reactive, these things are there. So that can be adopted and we can communicate the hazards of substance being used. Okay. So this is, we did this area of what are the exposure and these are samples. We did the cost analysis and this happy and happy performance we did. Okay. Then cost step. So hazard identification. Then work environment monitoring, that is to be done. Fugitive analysis or work environment analysis we do. Then JHA, job hazard analysis, particular a person whether what is exposed during doing a job, any obnoxious smell, these are not in the list in that 1 to 9 or in the manufacture import hazardous chemical rules, but during the work, this welding, some smell will come, or if it is at confined space entry, there also, that is more important, there more hazardous chemicals are being involved. Okay. And after that, you know, this communication system, training and rehearse of this mock drill, that what type of action they are taking during this type of leakage or this type of disaster. Okay. So this sample assessment for dust we did in ICI. That's why it is being just displayed. Okay. A sample assessment for hazardous chemical also we did. No, this is not so legible because you know this is little bit confidential because particular companies, this is assets we did. Okay. So, and employee should be responsible to participate. Sometimes you know what happened, the employee become afraid. If you tell that this is the hazardous chemical and you have to take step, they become afraid that, oh, it is very, very dangerous, so we don't want to work like that, or we don't want to use the personal protective equipment. So many things are there. So that's why this training should be taken by them and they should participate in the management program. Watchman participant, there is one topic also there, what subject is there also. So by that you can go for a sustainable development for the industries. That what is the aim of this particular session. Okay. So you see, that is the basic message for an investor. Those who want to invest in anything, first of all identify the hazards. Otherwise, what will happen? This will be just like Pustakassa tuja vidya parahasta gatang dhanam karjakale samutpunne naso vidya tato dhanam. So this message, as a veterans member of National Safety Council myself, I always communicate this. It makes 1 minute to make a safety rule. That's why this, after series of ammonia leakage in Calcutta and Howrah area, Pollution Control Board made one rule that ammonia should be abolished from the as a refrigerant and another chemical will be introduced. Senior law officer was there that time. I know him, he is my friend also, Mr. Mukherjee. So he was also telling, yes, we have to do it. But I told that you cannot do it. You cannot do it. It is not possible. Cold storage will be shut then forever. So this is very much important, this message particularly. So always please be careful because it takes lifetime to save people at home, outside, everywhere. So control of substance hazardous to health is so much important because if you do just one mistake in 1 second can take a life, and all these records what we have done so far can be just destroyed. Okay? So, thank you very much, because since this is lunch time, you must be hungry. If you have any question, please come out, or anytime you can disturb me. I am just sharing my experiences only. Don't have much of knowledge. My students, although they tell me always, okay, so but any question please?
Any question from the audience regarding this lecture?
सर
Yes.
वो आईसीआई में जो हाइड्रोजन का बारे में हम लोग जानते थे, वो उसका बारे में डिटेल्स बताइए ना.
Okay. That is, you see, hydrogen is not toxic gas, but it is very, very dangerous. Because you know, hydrogen, it has got a tendency, if it leaks, it generates static electricity and it catches fire. And that fire is invisible fire. Invisible fire. Only just vibration in the air, you can just identify hydrogen. So it is very dangerous. So that's why wherever there is a hydrogen modules are there, in hydrogenation plant particularly, there we always insist that there should be sensor and also vibration sensor. Because if the air vibrates, then there will be alarm. Okay, if it leaks, then only you can identify. So hydrogen is so much dangerous. That's why, you know, and wherever people are using hydrogen cylinder, they should use non-ferrous tools. Non-ferrous tools. Bronze or gunmetal. Am I right? Okay. Anything else? Very important.
Any other queries from the audience regarding this lecture?
Okay.
Hazard in the cold storage.
Yes.
Storage gases, the hazards are
Yes.
cold storage.
Yes, cold storage. Ammonia is used, isn't it? Ammonia is used as a refrigerant. Ammonia is very hazardous. You see, hazardous means that is flammable, explosive. Okay. So that's why whenever some repairing is being done, ammonia to be isolated first. Otherwise, these all accidents happen during repairing of the cold storage. It has happened. In Howrah, I have shown that slide, that is in Murshidabad, one happened, and recently one also cold storage during repairing, maintenance, and this happened. Okay. So ammonia is really dangerous. So that's why we always insist that before any repairing work, you should just isolate the ammonia, keep there the fire extinguisher, fire systems, okay, and the mask. Anything else? Anything else? I am insisting one thing, just although you have not asked, about the LPG cylinder at home. You know, because I am telling you, control of substance hazardous to health. LPG regulator, it fails, you know. I have seen it at my home. Regulators sometimes it become direct. So what happened, you know, just catch a fire. It was just firing violently, and the chimneys, it was damaged. Oven, it was damaged. So regularly you should check that regulator whether it is regulating properly or not. Please be careful. Since I have seen, I am sharing my experience. It happens. And the LPG also having the explosive mixture concept. Previous days, this cooking areas were closed. All the kitchens were being closed. When we are going out, we should keep the cylinder outside. Nowadays, that's why, you know, you will see all the kitchens, they are having an opening. You will see. That is the building code, National Building Code, Fire Protection Code. Okay. So many things have happened. You can always discuss with me or share my experience. I will share my experiences. Okay. Any?
Are there pressure cooker or hazard?
Pressure cooker, hazard study. You saw hazard study class, those you have attended, they are surprised that hazard study can be done for pressure cooker. Yes, I told. You know, that leader, hazard leader, I asked them, the pressure is the main criteria. PV is equal to nRT. We have seen that, if pressure rises, temperature will rise, boiling will be cooked very quickly. Okay. So that's why this will be cooked very in short time. Okay. So no pressure means atmospheric pressure. How this no pressure comes? Then if the lids are kept open. Okay. What is the hazard? There may be some insect inside, so that may be poison like that. High pressure, how it happens? You know, wherever you cook pulse, it just block the port, okay, that leads, and it comes like bullet if high pressure develops. Okay, so what should be done? They have done also a hazard study, pressure cooker. They are telling that whenever you are cooking pulse, dal, you should use the separator. But we don't use. Our ladies do not use. So what they do, as an alternate, they put a few drops of mustard oil, so that it does not froth, it does not come in the pot. Okay? Or a plastic, just a plate, just put on while cooking the pulse or dal, then it will not block the pot and the pressure will not be developed. Okay. And that's why there is a safety valve also, small safety valve nowadays developed. So, but that also sometimes fails if not maintained properly. So regular maintenance should be done. And previously, Prestige cooker, they did one gasket release system in the side. Gasket release system. If the pressure rise excessively, then the pulse will come out. Okay. So, am I clear or anything to tell? Okay. Pressure cooker have back flow, do you know? Sometimes I am telling just from experience. Pressure cooker, if you release the pressure very quickly, that's after that if you put in a water tray, just reverse way, if you just put, what will happen? It will be cooled and the vacuum will be created, and the water from that basin will go back inside the pressure cooker, and it will spoil your food. Please remember that. Okay. So during hazard study also I have explained that. Okay. Any more? Any more, sir? Welcome.
Thank you, sir. So the plenary lecture is now given by Sri Shamol Ranjan Maiti, HSE guide, accredited Hajab leader, ex-ICI Rishra. Thank you, sir. Thank you for your very nice presentation.
Thank you.
Now we are very glad to announce that Professor Dr. Raman Singh, Professor, Department of Mechanical and Aerospace Engineering and Department of Chemical and Biological Engineering, Monash University, Australia. Sir, please be seated here.
We would like to felicitate you with flowers, badge and memento. Professor Raman Singh's primary research interests are in the relationship of nanomicrostructure and environment-assisted degradation and fracture of metallic and composite materials, and nanotechnology for advancement mitigation of such degradation. He has also worked extensively on use of advanced materials for corrosion mitigation, stretch corrosion, cracking, and of magnesium alloys, including of the use of magnesium alloys for aerospace, defense, and bioimplant applications. So we would request you to, you can start your presentation.
So how do I move my slide? Yeah, okay, good, thank you. Look, it's my great pleasure to be here. I don't know how I got invited to this conference because I don't work as much in the domain of safety, but anyway, I will try to make it relevant. While I was sitting in the chair, a few things came to my mind. That it's good that I came to this conference because I chair the safety committee of the entire faculty of Monash University, engineering. And I will share a few of the tips which is relevant to safety in research domain. And I will try to go through the talk very quickly because I don't want to be standing too long between you and your lunch. I understand you all are waiting for lunch. I don't want to be too unpopular. I have to spend 2 more days here. Yes, so thanks once again to the organizers. It's first time for me to be in Haldia, but not first time in Bengal. I did my PhD from IIT Kharagpur. As a matter of fact, I'm a guest professor there for 1.5 months, and I thought that Haldia is not too far off, so why not take this opportunity? I always, whenever I get invited for giving a talk in any conference in India, I never say no, because this is one of the ways of giving back to the country which invested in my education. And that's the primary reason I don't see which place and all that, yeah. During this 1.5 month of stay, I'm giving, I think, I'm attending, I've already attended 4 conferences in 6 or 7 days, and I'm attending 5, 6 more. And I just say yes to every conference in India, not everywhere else. I have traveled around the world. I don't think there is any country where I've not been to. I've been to the United States perhaps 20 or 25 times. But I don't say yes to everybody else, but to India, I never say no. Yeah, because it's my duty and I feel proud. I was born in a village in India, in Bihar, and I did not see electricity until the age of 15, only when I went to college. So I grew up studying using lantern and candles and all that. And I'm not saying this with any sense of deprivation. I'm saying it with the sense of pride that I had opportunity of seeing people at every walk of life. People at lowest level economically and people at highest level. I must have had lunch or dinner with at least 7 or 8 Nobel laureates. In fact, I published a paper 2 months ago with a Nobel laureate. So I have seen life at every stage, and I feel very fortunate that God has given me this opportunity to see life at every stage. So that's my personal side. I don't want to be too emotional. Coming to the theme of this conference, safety, and as I said that I am the chair of the whole engineering faculty, safety committee of whole engineering faculty. A couple of things about safety that comes to my mind immediately, and I'm pretty sure that those who are expert in the area of safety, just my preceding speaker, will appreciate it. The whole beast, whole domain of safety is becoming far more important in research domain. And the reason is that research is becoming more and more interdisciplinary. What I mean by that, you will find quite a lot of people who are now working in mechanical engineering domain on a topic which is related to biology or chemicals, and vice versa. And because of training, they may be aware of safety in mechanical domain, but they don't know much about safety in electrical domain or safety in chemical domain or biological domain. And I will give you one example. I had a student who was a mechanical engineer. I'm a materials person, who was given full training of using chemical lab, using globe boxes, using all sorts of equipment which he was supposed to use. And he did he had the job of doing etching using a chemical, right? He had all the training, but while actually using the chemical, he was sticking his head inside the fume cupboard and then doing the etching. Means the person only ticked the boxes, did not understand what was required for safety training. I had, in fact, accident in my lab. I was away in France, and then there was a big accident. It was fortunate that nobody was there in the lab, otherwise it could have been fatal. Why it was so? Because person was from mechanical engineering. He did not know that while disposing the chemicals, acids and bases should not be disposed in the same waste bottle. And it led to explosion all of a sudden. And the bottle didn't have vented caps. I think you will appreciate what I'm talking about. So these are the challenges which we should be aware of. At Monash University and in most universities in Australia, the person who is in charge of the lab, the supervisor, is legally responsible for what is happening in his or her lab. And that's how safety is evolving, and that's how it should be, because human life is far more important than anything else. So those were my quick thoughts about safety. So because it is safety conference, so sitting in the chair, I thought I should share a few things with you. It is extremely important. You talked about MSDS, material safety data sheets. At Monash, I cannot order any chemical, even if I have money, I can't order any chemical unless the safety officer of my department approves it. The order cannot go out. And that way, the safety officer is legally responsible for if something wrong has been ordered. So those are the things. Look, coming to my talk, I don't know how many people are interested in materials. Raise your hand. Okay, I have a few people in the audience. I will try to make it a bit quick. Raman Singh is my name. I published under this name, the same person. For the benefit of Westerners, I have shortened my name because Indian names can be tongue-twisting and difficult for Westerners anyway. I have joint appointment between these two departments, and once again, I'm thankful to the organizers for making it possible for me to be here. Corrosion is a big issue, and it is very relevant for environment, one of the topics of this conference, because if you did not address the problem of corrosion properly, first of all, it is a big dent in the economy. It costs hugely. But it can sometimes, because of lack of knowledge, it can sometimes lead to catastrophic failures. I will give you an example. We know that we lose metals because of corrosion, because it reacts with environment and you lose it as corrosion product. But the combined effect, the synergistic effect of mechanical loading and corrosion can be extraordinarily catastrophic. Those who know metals and materials will also know that if I take a metal, as long as my applied load or the load of a pressure vessel or whatever is within the yield stress, you can feel safe. That material will not deform, it will not fail. That's not correct. If you have combined effect of stress and corrosion, material can fail below yield stress. You might have thought that you have designed your component for rest of the life because your applied stress is below yield strength. But if you have combined effect of stress and corrosion, and I don't have time or perhaps relevance for going into the details, but take my word, it can fail below yield strength, and all of a sudden your pressure vessel may crack, and there have been catastrophic and fatal failure because of the phenomena which is called stress corrosion cracking, right? There is one famous example from Switzerland that there was a swimming pool, and in swimming pool you use chlorine, okay? And for better acoustics, for better sound effect within the swimming pool, they used a ceiling which was hanging with the help of stainless steel. They did not realize there is a phenomenon called stress corrosion cracking, which happens because of the combined effect of stress, which was because of the ceiling, and chloride environment. In the case of stainless steel, chloride came from where? Because you use chlorine in the swimming pool. So here you go, and 13 people died because one fine morning, because of stress corrosion cracking, the ceiling rods of stainless steel failed, ceiling collapsed, killing 13 people. Here you go. So those are the kind of things that can happen if you did not understand the phenomena of corrosion. I'm here to quickly share with you, I will go through my slides very quickly because I know that in this audience there may not be many people much more appreciative of that. Graphene coatings are disruptive approach. Why it is disruptive, I will quickly go through that. As I said, corrosion is very expensive. United States loses about $300 billion every year because of corrosion. Any developed economy or developing economy loses about 4% of its GDP through corrosion. And corrosion has been there ever since we started to use metals and alloys, right? If you know fundamentals of producing metals and alloys, you will appreciate, and I'm happy to talk to anyone who has questions along those lines during lunch. So corrosion has been there for a long time, and it is expensive, as you saw in the last slide. So people have been doing a variety of things for addressing corrosion, like having corrosion-resistant alloys, stainless steels, aluminum alloys, or having coatings, right? And cathodic protection and so on and so forth. So they have exhausted almost everything that you can do for addressing the problem of corrosion because it is so expensive and because it is so old. So doing anything disruptive in a domain which is old is very, very challenging. But if you did anything disruptive, rewards are huge. You can appreciate that you don't need to use stainless steel at all. Graphene coated mild steel will be working better than stainless steel. And that's the kind of thing this talk is all about. If you have graphene coated nickel, irrespective of the aggressiveness of the environment, whether it is sulfuric acid environment, alkaline environment, neutral environment, it gives corrosion resistance in the same way. Why I'm saying that? Because intercept of these two arms gives me same value. You can see this is corrosion resistance. I will not go into details. Whereas the bare nickel will corrode differently in different environment. Today we are talking about energy and different types of alternative energy sources, and fuel cells are one of those sources. Proton exchange membrane fuel cell, its bipolar plates operate in highly demanding condition, highly acidic condition. And if you have proper nickel copper alloy coated with graphene, it gives huge corrosion resistance. Those who work in the area of corrosion will be very, very pleased to see this kind of behavior. What it means is that you are forcing the material to corrode, and this material, nickel copper alloy coated with graphene, refuses to corrode. Why I'm saying that if there was no coating, you can see there is huge, very rapid increase in current, the bare alloy, whereas the coated alloy refuses to corrode, and seeing is believing. See, there's not much corrosion happening in the case of this alloy. Also, it is challenging, it is technologically challenging to develop graphene coating on mild steel. But we have succeeded in developing graphene on mild steel, and this has been published in two, very recently, this year and last year. These are very reputable journals with impact factor between 10 and 15. And you can see that graphene coated mild steel does not undergo much corrosion. So how it was possible is because of graphene. How many of you know about what is graphene? Raise your hand. How many of you have heard about graphene? Okay, good. I have at least one, oh, two, okay, two customers. Graphene is an extraordinary material, but graphite, everybody has heard. Don't tell me that graphite you haven't heard. Most people would have heard of graphite. So if you separate a single layer of carbon from graphite, that is graphene, right? And if you did it before 2009, you would have won Nobel Prize, because Nobel Prize was given for just doing that to two scientists from University of Manchester. This graphene is the most researched material of recent time. Why? Because it has extraordinary properties. Electrical conductivity, thermal conductivity, electron mobility, surface area, all these things are a couple of orders of magnitude superior to its competing material like metals, any metal. Okay? Graphene also has very good mechanical properties. It is about 100 times stronger than the strongest steel, right? And it is still tough. Generally, a material which is strong has less toughness, like ceramics. Very strong, right? But they are brittle. If you drop it, they crack. Okay? Graphene has both strength and ductility or toughness. Graphene also is inert. Even hydrogen fluoride cannot react with graphene. One of the mechanisms, or the common mechanism for common coatings to fail, is that it reacts with environment, with UV ray, ultraviolet ray. Polymer coatings react with that, and they degrade, chemically degrade. They can react with alkali and all that. Graphene does not react with a chemical as aggressive as hydrogen fluoride. And also it is impermeable. Most coatings fail because the corrosives can pass through the coatings, like water, chloride, or oxygen can pass through coatings. The tiny hole that you have in the middle of this hexagon of graphene is so tiny that even helium can't pass through. So larger molecules have no chance. So can graphene be, on the basis of those properties, can graphene be an ideal barrier coating? I wouldn't go into the details of how we develop graphene. I don't think we develop quite often the graphene on copper and nickel, because using hydrocarbon, simple hydrocarbon like methane and cyclohexane, you can develop graphene on these metals. I will not go into details because it is intriguing. People worked before us on graphene coated copper, and they showed that it gives very good. That was the first paper after graphene won Nobel Prize on graphene for corrosion resistance of copper. We were perhaps the first people to work on graphene for corrosion resistance systematically, and that work was published a year later in 2012. This is one of the most cited papers, cited about 600 times. One of the most cited papers on the topic of graphene for corrosion resistance. So, I have reason to tell you, based on this spectra, Raman spectra, that it is a single layer graphene. It is a single atomic layer thick graphene. And that improved corrosion resistance by 100 times, as you can see, that it is log plot. Data are missing here because of computer here. So, it is here. See, it is 100 times superior corrosion resistance due to graphene in highly aggressive chloride solution. One atomic layer thick graphene, right? And and other technique also proved that. Different people were working on graphene. Our group showed 2 orders of magnitude improvement. Around the same time, someone else was saying that graphene, in fact, accelerates corrosion. I don't know how many of you have electrochemistry background or knowledge. It is because of electrochemical aspect. If you don't have proper graphene, if you don't have continuous graphene, then it will not work, because graphite is very cathodic. You attach it to any metal, it will force it to corrode more. And we mentioned that in our paper that was published just a year ago, just a year before this paper. So graphene has variety of problems. It can have wrinkles and all that. So can we develop defect-free graphene? Answer is no. Defect-free single-layer graphene development is difficult. How can we address the problem of such discontinuities and defects? By having multi-layer graphene. As you can see, multi-layer graphene here. And that was the hypothesis of my first PhD student on this topic. And that graphene did give long-term corrosion resistance, unlike what was claimed in earlier papers. Those papers were published in very reputable journals, I can tell you. It's a typical story where some new material comes, anybody works on that, and they publish in very good journal, because it is new without going into the details. So multi-layer graphene was important. We managed to develop multi-layer graphene on nickel by controlling parameters, and you can see this is multi-layer graphene on nickel, which gives very good corrosion resistance, as you can see here. And we did some work whether it can be applied to bipolar plates, as I talked about it earlier. The graphene-coated nickel gives very good corrosion resistance, as you can see. And so it's very important that I'm talking about bipolar plates, because the bipolar plates had two very strong requirements. Can you not talk? You're welcome to leave if you don't want to. Yeah, you don't have to be here. Why feel bored? Why listen to someone whose talk is boring? But anyway, so sorry, that's how I get distracted. So I was talking about bipolar plates. Bipolar plates have this requirement that it must have corrosion resistance, and also it continue to be conducting, right? So even if they use the best corrosion resistant alloys, with time they develop corrosion film, because it is highly aggressive environment of sulfuric acid. And the corrosion film that you develop will be at the best semiconducting. So you will lose conductivity. Graphene addresses both the problems. It gives you corrosion resistance, and also it is conducting, as I said earlier. So it's a beautiful replacement. If commercially we could use graphene-coated mild steel for bipolar plates, it is a multi-billion-dollar achievement, I can tell you. And we are working towards that. And again, these papers have been published recently in a very good journal. Carbon is a very good journal. And we could show that it is long-term and all that. Trust me, I will not take too long. I'm already trying to go fast. Okay. And this you have already seen, that if you take proper nickel-copper alloys, 67% nickel, 33% copper, and develop proper graphene, multi-layer graphene, this behavior is really, it is a sweet music to the ears of those who work on fuel cells. And it is reproducible data. As you can see, graphene-coated one behaved very well. So what I showed you, that we develop graphene on copper-nickel alloy. Can we develop on commercially large scale? Can we develop graphene on mild steel? I will take a couple of minutes, and then I will a few minutes, 5 minutes at the most. So we showed that if we have tilted the substrate while doing CVD, chemical vapor deposition, after tilting, you have much better graphene, much less disruptions, defect-free graphene. Whereas 5-degree tilted has lots of defects. 45-degree tilting, not much defect. And this paper is coming in small, so very reputable journal, early next year. And we did Raman spectroscopy to show that yes, we have good quality graphene when you have 45-degree tilting. Also, electrochemical tests showed yes, 45-degree tilting is much better. You can see that it is intact, whereas 5-degree tilted disrupted and suffered corrosion. For the first time, we used this spectroscopy, scanning photoelectron microscopy for detecting graphene or doing graphene-related work. First time it was used for corrosion research, and it was with the help of synchrotron people in Trieste in Italy. Our colleagues in Italy, they helped us. So you can see that 45-degree tilted, a very uniform graphene everywhere, whereas 5-degree tilted had disruptions, and disrupted area showed nickel, which got reacted with sulfuric acid, and that's why sulfur signal as well. I will take 2 minutes and talk about how we could develop graphene on mild steel. It's an interesting story. It is challenging. Anyone with the background of metallurgy here? No. Okay. So I will tell you, it is difficult to develop graphene on mild steel because of metallurgical reason. Because at the temperature of CVD, which is about 900 to 1000 degrees Celsius, mild steel is in a kind of phase which absorbs a lot of carbon, which defeats the business of having right partial pressure of carbon to develop graphene. That's the main reason. I will not go into details. So it is difficult. It is difficult. So, but earlier we showed that we can develop graphene on nickel. Why don't we put a thin layer of nickel on mild steel and then develop graphene? Very simple. It's not rocket science. It does not work. Reason is, whatever carbon diffuses in nickel, it continues to diffuse into steel. Both nickel and iron has very good solubility of carbon. So you lose the carbon that you require for graphene. That's the main reason. So that's what really happened. We put a thin layer of nickel, tried to develop graphene, we could not succeed. So what we did, we put another layer of copper. First put a layer of copper and then a layer of nickel. Why? Because copper has almost nil solubility of carbon. So then carbon cannot leak into steel. That's what we did. And when we optimized that, diffusion calculations of metallurgy was used. I will not go into details again. When we optimized that and then we did CVD, we could develop beautiful graphene, as you can see, for the first time. And it was published last year and this year. And this was for the first time anybody developed successfully graphene on mild steel. And because this graphene layer has all the characteristics that it will not fail with time. Why I'm saying that? I gave you the characteristics of graphene, which is that it is impermeable, it does not react chemically, and it is also tough. If you have graphene layer on mild steel, you bend mild steel, graphene will bend along with this because it is ductile, it is tough, right? There is no other material which has all these properties in one material. So we believe, I didn't have chance, or nobody will have chance to do everlasting test, but we don't have any reason not to believe why graphene should not be everlasting coating, which we have never heard of. There is no such thing under the sun currently called everlasting coating. Every coating fails eventually. Coating on your car fails. Coatings on any other item fails. And there have been a few people who are partners in the crime. Tanuj Joshi is my current PhD student. Nikita Chitre is finishing her PhD on this topic under the joint program of Monash University and IIT Bombay. It's called IITB Monash Research Academy. Then next four, Dr. Arya, Dr. Sanjit, Dr. Ansur, Dr. Abhishek Tiwari were my PhD students who worked on this topic. Others helped. Others were also PhD students in my group, but they helped. Lokesh is working with Philips in the United States. Parma Banerjee is my colleague at the same university. Others are PhD students gone away. Mainak was junior academic when we started the work. He is now a full professor at Monash. Last 5 names are very, very important. These are undergraduate project students. So our first work, which was published and has been cited so many times, was done as part of the undergraduate project. And I take pride in saying that. I must thank Professor Ajian. I don't know how many of you know his work. He's one of the most cited persons in the world on graphene and such materials with H index of 215. So I interact with Ajian quite regularly. We are writing a review paper together. I met him last month at a conference in Australia. So these are the people who have been partners in the crime on this. Sorry if I took a bit longer than intended. Thank you very much.
Any other queries regarding these topics?
Just one question. If you tell something about the local cell formation,
Due to what?
Local cell formation using the cascade cooler design or showing when flowing the sulfuric acid manufacturing. Their local cell formation and corrosion is developed there very quickly, whether it is graphene or anything else.
No.
Yes.
Let me answer your question. Thank you. Thank you. Thanks.
Sir,
Yeah, I'm answering his question. Yeah. I was thanking people who were talking. Yeah. Right. So your questions had a few different parts. One is, if you have discontinuous coating of graphene, then it is very dangerous. Why it is dangerous? Because graphene is highly cathodic. So the bare area will be corroding at much faster rate, as a matter of fact. And that's why they were saying that graphene coating accelerates corrosion. It's worse than nothing, right? And that's why we say that we must have multi-layer graphene. The purpose of that is, wherever you have discontinuity, the subsequent layers mask it. Does it answer your question, sir? Yeah, thank you.
Thank you.
Thank you.
But we have faced that.
Yes.
Sir, thank you very much for this interesting topic. I've spent 40 years in industry, but I have never heard this topic, this graphene coating. Sir,
You're not alone. Nobody heard about it before 2010.
Sorry.
Yes,
Sir,
yes.
one part you have not covered, that is the cost part, because in industry you always talk about cost. So can you give me some idea, because conventionally you go for...
I got your question, and you're not the first one who is asking me this question. I've given this talk maybe 20, 30 times.
So
Can you not talk? Can you get into the habit of not talking? I'm talking to you.
Corrosion is a part of your...
No, see, if you're not interested in discussion, go out. No problem. Beautiful air there. Environment is very good. Climate very good. Enjoy. All right. So I will get to your question. Yeah. Cost. People have this notion that anything that is new must be costly. When I develop graphene, what I'm using a CVD furnace. When you are producing steel, you have different thermal points anyway. You have one more point with CVD. Now, what are the chemicals that you use? Methane, cyclohexane. Tell me how costly they are. Not at all costly. It is much less costlier than the stainless steel or chromium that you use. Chromium is an expensive element, very expensive. So cost is not the factor. I will tell you where is the challenge. You are the industry person. I will tell you where my difficulties are. We have solved the science part of the story, that how we can develop graphene. I am working on solving the engineering part. Right. What is the engineering part? How I can develop this coating on larger surface. If I give you the results out of coupons, it will be of no interest to you. So we are working on that. Part of that we addressed, in fact. See, earlier we were developing graphene on much smaller area. By tilting, now I'm in larger area. I'm not at liberty to say, my current student, Tanuj Joshi, is exactly working on that, how to solve the engineering problem so that we can develop graphene on larger area. Does that answer your question, sir?
Okay, thank you very much. So another point, earlier you started with stress corrosion cracking, no? This cracking because of high percentage of chloride. Because I was related to port, and I have seen nowadays marine vessels of the order of maybe 100,000 ton or 200,000 ton, and that vessels are highly susceptible to chloride corrosion.
Stress corrosion cracking.
Stress corrosion cracking.
Yep.
So will it be effective for those type of vessels?
Answer, look, I have not done tests, but answers are this. When you say stress corrosion cracking, it is a brittle type of failure. A tough material starts to behave brittle because of stress corrosion cracking. And if there is opportunity, I can give another talk tomorrow on that. I have talks ready, no problem, yeah. So, because you're interested, or I can give you a talk one-to-one to you, yeah, right?
I'll discuss.
So the answer is that because graphene is tough, right? So first crack will take its time before it develops, because if you go into the mechanism of stress corrosion cracking, the cracking of the oxide scale at the crack tip is what governs stress corrosion cracking, right? If you have a tough material at the crack tip, that will delay the cracking. There are other ways of handling it as well. If you have interest, I will be very happy to discuss with you, because my group has been working since 2005 on the stress corrosion cracking heavily. As a matter of fact, my group perhaps might have published maximum of number of papers, more number of papers than anybody else in the world on stress corrosion cracking.
Just one last question.
Sure.
Sir, can it be studied it application in cryogenics?
I personally feel, I don't have exact data and I can look into it. That's a very good question. Because when you talk about cryogenic applications, we can't use normal mild steel because its ductile to brittle transition temperature is around room temperature, depending on which steel you use. So what you use? You use materials which have better ductility. What are they? You have austenitic stainless steels, which can work at much lower, which has ductile to brittle transition temperature much below -50, which is cryogenic temperature, or aluminum alloy. Because this material is inherently so tough, so
normally, for example, in ammonia, he has also handled. Normally in ammonia, we use cryogenics. There will be handle low carbon steel only. So there's no alloy steel. And there's
what is the temperature, sir?
At temperature around -40.
And you use mild steel. You kick your
no, that is only low carbon steel.
You use low carbon steel.
Yeah.
You kick the material when it is cooled. If it does not crack, I will take you out for lunch.
But it is recommended for that, recommended for ammonia also.
What is, for low carbon steel, you tell me what is the ductile to brittle transition temperature. That decides whether it will be brittle or not. Ductile to brittle transition for any steel has to be in the range of, at the best, -5, at the best. We have famous example of Titanic.
Titanic.
That failed. No, not Titanic. Titanic, the ship.
Titanic, I have studied that.
It happened because of that embrittlement.
Embrittlement, yeah.
So
that is because of high ferrite.
Yes, because of high carbon, because it was ductility even at 0 degrees Celsius. Yeah, we can talk. I don't want to hold people for lunch. They will start to shout. I have already quietened them a few times.
Thank you very much.
Yeah. Thank you. Don't take it personally, okay? Thank you.
Any other queries from the audience side?
There's one more question from this.
Actually, what about the thickness of your thickness?
If you have single layer graphene, it is 1 atomic layer thick. It is nanometric thick. If you have 6-7 layers, it is a few tenths of nanometers. If it is 10 layers or more, it is not graphene anyway. It is graphite. More than 10 layers is graphite. It is brittle. No, if it is brittle, then it defeats the purpose. So you have to have 6 to 7 layers. We never go above 7 layers. Yeah. And I can determine that by Raman spectroscopy how many.
If the substrate is pure, some other than nickel, copper, or pure iron, so the process.
So if you have that, I will first deposit a layer of copper, then nickel, and then deposit graphene, as I showed in the last slides. Yeah. Thank you very much. Sorry to be. Yeah. Thank you.
Thank you also very much. Obviously, very
Thank you.
Thank you, sir, for your very nice presentation. You have nicely presented how graphene is used for the corrosion resistance material. So I think you have already enjoyed this plenary lecture. Thank you, sir. Thank you once again. Now we are going for lunch.
Thank you.
Now we are going for lunch. Again, we meet in the 3rd floor for oral presentation of a poster presentation. Poster session will be conducted at 3rd floor. After lunch, we will meet again at 2:30 p.m.
What do you students study? No study. Your work. Sorry,
Good afternoon, everybody. Now we are going to start the post-lunch session, that is poster session. So poster will be presented by Ms. Tanisha Mukherjee, HIT, means Haldia Institute of Technology, Department of Chemical Engineering.
Sir, the change টা কিভাবে ঠিক আছে এটাতে আসছে পরেরটা আসছে তো ঠিক আছে oral presentation Good afternoon, everyone. So today my topic is chromium removal from wastewater by the use of banana peels. So here are my contents that includes introduction, materials used, methodology, data analysis, ANOVA tools, that is the ANOVA software used, then optimization and kinetics, then bioseparation processes, literature comparison, and conclusion. So the introduction. So why we need to remove the chromium from wastewater? Because due to the industrial pollution, mainly in the metropolitan cities and in the refinery-based cities, like Haldia itself, the water used in the refineries consume lot of lead, chromium, iron, these kinds of substances, and metal oxides that need to be removed. So that need to be removed from the water to make it domestically sophisticated and usable for the people to drink and for other purposes. That's why I need to remove the chromium from the wastewater, and for that we are using the banana peels, because banana peel is a renewable material, that is a biodegradable product that we can make it as an adsorbent and finally remove the chromium from there. So this is an industrial built pollution that we have collected. Now the adsorbent preparation. So how do we make the adsorbent? So we are using first the banana peels. After by the drying process, the peels are removed from the oven and kept in the desiccators for 30 minutes. In the analysis process, we have presented our time in 60 minutes. For the drying process, here drying the peels for 30 minutes, and the dried material are then finely ground and then screened through the sieves of cut size through 150 to 212 nanometer. So these are the grind substances of the banana peel after drying. Now the methodology. Now we have to conduct a market research and analyze the target audience to identify the opportunities of the banana peels. Why banana peel is being used? We can also use the other biodegradable substances like the moss and algae as well, but banana peel is considered one of the better adsorbent material for this. Now we have to create the product or service it by defining the features, design and functionality, then test the product with a group of users to receive the feedback and improve the product, and then execute a marketing campaign to promote the product to the target audience. Means the wastewater after removal of chromium, we will by the use of banana peel we can make it to the target market to buy it and to promote to the users. So next is the procedure. So the procedure includes the banana peels that can be obtained from the local markets or the other household waste. The peels should be thoroughly washed to remove any dirt or impurities. Then chromium solution, a stock solution of chromium that can be prepared by dissolving the potassium dichromate or chromium nitrate respectively in deionized water. Then chemicals for adsorbent preparation. Depending on the pre-treatment method, various chemicals are required such as hydrochloric acid, sodium hydroxide and the other activating agents. Some other catalysts could also include the AuNPs, that is the gold nanoparticles, that could activate it as a catalytic solution. Next, for the data analysis, we are using the ANOVA tools that provide deep insight to the inside where operational friction is occurring, that help into drive efficiencies and minimize the capital costs and prevent the product loss. So the ANOVA results for the quadratic model are represented as a model of F value that indicates the model is significant only with the value that could be occurred due to noise. So the significant model is mainly compared by mass of absorbent and versus removal and the quadratic team for mass of the solution. So here we have also calculated the 3D response, that is how much absorbent material is obtained from the solution and how much we are obtaining from after the removal process. These are some calculations done for the surface, the sum of squares, the mass and the F value and the P value. Now the ANOVA tools. So the ANOVA software tools that we have used that results in the quadratic model, we will obtain a quadratic model as a graph where G is represented. The model will indicate 707.17 that are significant only with the F value. Here the 3D response surface plots illustrate the interactions between the factors and their effects on the overall, that it shows that increase in the increasing of mass of adsorbent will be relatively unaffected by the time. So that G will initially increase with the increasing percentage removal, but then will decrease after reaching a maximum. Now it suggests that the mass of adsorbent has a more significant effect on G than the percentage removal, and there is a significant interaction between these two factors. We'll show the next graph. So this is the analysis we have got. In the first figure, the optimization is being started, and second figure we get a plane surface, parallel surface, or that is a plane surface absorbent, and in the next figure we are again obtaining reverse graph that is going through another side, and again we are obtaining a parallel. So in this process we are obtaining 3 results consecutively in this method. Now the optimization and kinetics. So we have calculated for QE time, that is 60 minutes as far as said, not per as the drying time. So for the QE time we have calculated 60 minutes, that is 1 hour, mass of adsorbent that is 0.5 gram and removal 30.65 with the predicted maximum of QF 0.591 G, it is gram. And for G, it's 60 minutes, mass of adsorbent 0.5 gram per liter and removal 30.65 with predicted maximum of 0.474 gram. So these optimum conditions suggest that longer contact time, lower mass of adsorbent and the higher percentage removal lead to the maximum absorption capacities for QE, and that is discussed. And the kinetic study reveals that the absorption process followed by a pseudo second order kinetic model and a Friedrich model, indicating that the rate limiting step involves chemisorption, involving the valence forces through the sharing and exchange of electrons between the absorbent and absorbate. These are the results obtained. These are the contour plots of optimized solutions. 3D plot, that is a 3D response calculated for optimal solutions, and the RAM desirability for optimized solutions for the various ANOVA results that we have analyzed before. Now the bioseparation process. This entire process is a bioseparation process that uses the scientific and engineering principles to purify the biological products on a large scale basis to make it in an industrially feasible model. Now the goal of bioseparation is to refine the molecule cells and parts of cells into purified fractions, including the RO membrane. The bioseparation process also typically uses a series of independent stages, that is low resolution techniques, and these techniques are used to first reduce the volume of material being processed, and then high resolution techniques used for purification and polishing, and mainly to reduce the pollution. It also uses the biomass. In another slide, we can in another example for water treatment, we can use the biomass or the other biodegradable substances like moss and algae substance to make it a feasible wastewater treatment product by using the RO membrane process. This is the bioseparation process. This is one kind of distillation process where a metal recovery is done, so chromium could be easily recovered at the end. Now the comparison with the literature study, so we get the maximum adsorption capacities obtained in the study is 0.591 for G and for QE, and G is 0.474 G, that are higher than those reported for other literature compared studies by the use of banana peels. So we have required the reported higher absorption capacities by using the modified form of adsorbent. So this suggests that further enhancement in adsorption performance may be possible by modifying the adsorbent surface properties by introducing the functional groups. Now the results and discussions. So here we have used the pseudo second order reaction, Langmuir isotherm model, linear plot, and the Friedrich isotherm model. So the pseudo second order reaction provided a suitable and better fit to the experimental data as compared to the pseudo first order kinetics model. I cannot put all the data here as per calculations. These are some experimental data. Now for the conclusion, it demonstrates that the effective application of banana peel powder as a low cost effective absorbent for the removal of chromium from wastewater. Response surface methodology was employed to optimize the adsorption process parameters, including the contact time, adsorbent dosage, and percentage removal. The optimum conditions obtained were 60 minutes of contact and 0.5 gram per liter of adsorbent dosage and 30.65 removal to maximize the adsorption capacities. So it produced a better results as compared to the other parameters and other adsorbents used previously. So these are some references. These are an experimental study that we have done in our lab during the BTech time. So we have used the modified version of the adsorbent. So that's all. Thank you.
Thank you, Ms. Mukherjee. So any other queries from the audience side?
Thank you very much for this nice presentation. First of all, you are using banana peel. So actually you have told that you will collect those banana peels from household, no? From different houses. But do you think it will be feasible to collect banana peel like this?
We do not collect it from individual houses. The way household products that are collected means those are thrown away, let's suppose, from the sewage.
Okay.
Those are thrown away in the water. So that we collect it as a raw material. Let's suppose another biomass substances that are obtained near the rivers, ponds. We collect those raw materials as a substance, then we optimize it.
Okay, very nice. And whatever water you get, you are telling that about 39% or something that absorption. So what is the use of that water? How that water will be used? For what purpose?
From the previous studies, we obtained lesser material. So, compared to that, from the previous results, if you are using this adsorbent, we can produce a better result than this. So, we can use it for
longer period. Longer period to get a.
Yes, for longer period, and mainly for the household domestical, we can use it for a longer period of time. But
okay.
For industrial scale, we need to make it in a machinery for more
I mean, you have to increase the. Right. Yes. Very nice. Very nice.
Any other queries regarding these topics from the audience side? I think, Thank you, Ms. Mukherjee, for your nice presentation. So now we are going to start the invited lectures. The lectures will be given by Professor Dr. Pulokesh Bera, Panchkura Bonomali College, under Vidyasagar University, although it is autonomous. Sir, Professor Dr. Bera, please.
Good afternoon. I feel very good having here with you to share my some research work in a general degree college. My college is Panchkura Bonamali College, autonomous college, the only one autonomous college in the district of Purba Medinipur. So we actually NAG accredited 2 times A grade college. So anyway, it's my very small lab. I am basically inorganic chemist. In my earlier stage of research, I did some material science, nanocomposite and nanomaterials using the inorganic complexes. And now I turn in different field, bioinorganic. So so in my research time, I am not fixed in research field due to some very, what I can say, very some simple reason, money. Money is not there. So a grant always not actually received by me. So I am now restricted my research in bioinorganic chemistry. So today, actually, we are here in the national conference. The theme is HSE. The HSE stands for Health, Safety and Environment. Basically, if we are in good health, then we can do something. We can listen, we can learning. So health is very important one. So my research work actually concerning the development and application development of anti-cancer drugs. So the term is generally used after several clinical trials. But in my lab, only I just synthesize some compound having some drug-like properties. And we establish the structure, activity, relationship in experiment, tabletop experiments, and some theoretical, some process. So corroboration is there between theoretical and experimental data. So this is that. So what is actually, why does cancer occur? So we know the cancer is really very deep concern of the society, because many pupils, nearly 10 million people in the world in a year, actually death with this cancer. So cancer generally comes from the overproduction and malfunction of the cell, of our cell. So nobody knows when you will be affected by cancer. But scientists in all over the world, they are doing their research on cancer projects, and also the governments of the developing country, they are spending a lot of money to answer the cancer. So as a part of this, many such projects are running in the different part of the world. So how does it grow and react? So as I saw in my previous slide, that abnormal growth of normal cells, it actually invades the surrounding area of the part of the body, spread over the organs, and results in metastasis. It causes death. Here is one some pie chart, some statistics. So it is not visible. I think you cannot see. It is in the year of 2020, it's little early year. But you see here is one some data. Is not actually 24 and 25 data are not coming, but somehow we receive this amount. So you see the huge amount of people actually died with this cancer. So basically, what we can do to actually prevent primarily the cancer? What is there that prevention is better than cure. So we can prevent the deadly cancer by stopping smoke and don't take alcohol much or pan masala, gutla. And if you control your diet and also avoid unwanted or unnecessary medicine, taking unnecessary medicine. So what are the treatments so far? So first of all, you see that there are various stages of cancer. First stage, second stage, third stage. So if you are in first stage, then there is little chance to cure from the deadly cancer. So we actually, in this present slide, I wrote some the symptoms and signs. If you have that kind of sign and symptoms, so I will suggest you to consult a doctor immediately. So what are these? Weight loss, pain of different organ, color of the skin, changes or morphology, the skin, and unusual bleeding in various parts of your body, and persistent cough and voice, say it will persist more than months, change your outgrowth, any part of your body, anyone. If you have this kind of thing, so I will suggest you to consult doctors. So these are the actually some different kind of therapy. You see, radiation therapy, we are well known with radiation therapy, chemotherapy. Besides this, surgery is also there, we know all this. Besides this, there are many other patient to patient, varies patient to patient, different type of therapy, hormone therapy, stem cell therapy, hyperthermia, and immunotherapy, biomarker testing. Anyway, so my part is chemotherapy. That we develop some compounds which are useful for chemotherapeutic. So drugs are mainly metal free in chemotherapy and metal added. That means metal complexes. So metal free drugs are heterocycle aromatic compound mainly. These are all clinically supported and clinically tested. And metal added drug are mainly cisplatin, carboplatin, oxaliplatin, and ruthenium complex, and many other compounds. Each and every month, thousand papers related to oncology and related to cancer is published in different journals. So if it is not possible to show all the compounds name and others. Anyway, side effect of chemotherapy are there. These are the side effects. You see, many side effects are there. Then one question may arise. So then why we should go, but why we will opt the chemotherapy? Because if we consider the condition of patient after chemotherapy, so all these are actually the side effect. But slowly the cancer slowly the patient actually revived its original stage or status. Therefore, though these are the side effects, nowadays chemotherapy is also one significant therapy of cancer. Now, one thing is very common. You see, protein actually is a chiral, and it has some nitrogen, phosphates, that kind of atoms. So the interaction with some heterocycle generally happen or occur inside the cell. So to resist the proliferation effect, the heterocycle compounds are very effective in this respect. So we design such kind of compound, the heterocycle compound, maybe hybrid one, maybe only single one. This way we actually design the molecule. So what we people do? What are our contribution? You see, at first we design and synthesis of ligand. Ligand means here the heterocycle compounds. So after characterizing the ligand, even we are able to characterize all these by single X-ray crystallography. Then we go to prepare the metal complexes. That means the ligand and metal complexes. I think you know the complex, water complex. So metal complexes. Sometimes it has been seen that the metal complexes show better anti-proliferative effect than ligand, vice versa. Obviously, not always it is true. And therefore, we also prepare some metal complex with these ligands. So you see the characterization of ligands and complexes. This is one part. The instrumental part is there, IR, FTIR, X-ray crystallography. Then we found the optical properties, electrochemical studies, and some cyclovoltammetric studies. All these studies actually give the total characterization of the compounds. Without the full characterization, we cannot go further for biological evolution. Then we actually start the biological evolution with this new compounds, newly synthesized compounds. So generally, we have to check the anti-cancer property, whether it is the apoptosis or necrotic in nature. Therefore, we have to check first the cytotoxicity, then some others, LDH assay, PARP cleavage, gas-specific activities, screening in some PBMC, normal blood cell, DNA binding study, UV visible binding study with the UV visible spectroscopy and fluorescence spectroscopy, okay? And then we made on some structure activity relationship. So why this compound showing some anti-cancer activity? So let's see what kind of heterocycle compound we prepare in our laboratory, okay? See, this is HL2, this is HL2B, HL3, HL, so it is not visible, HL5, 4, HL5B, and these are L4C, L4D, and L4A, L5. So these, all these compounds, you see this one, this one, this one, this one, this one. Many compounds like this we prepare in our laboratory of Purba Pulmonary College. And then we actually prepare metal complexes with these kind of metals. You see, all these metals are found in our body. Copper, cobalt, nickel, zinc, manganese, iron, cobalt, nickel. So, biological study, actually we mentioned that in previous slide. So I can skip this slide. And you see, the HL2 compound that I show in my slide. So synthesis, characterization, and on pyrazine thiazole. Previous page. Okay. So this is actually one ligand, and these are the complex with PPR. And the conclusion, so I am not giving the details of some synthesis procedure, the characterization procedure, and the biological activities. But conclusion from the work, all work, I can see you, or I can tell you, the pyrazine thiazole derivative actually, the mixed type compound, hybrid type compound, based on iron 2, cobalt 3, nickel 2 complex, we synthesize and characterize. All these compounds show anti-tumor activity against U937 human monocytic cell. The activity order you see, nickel, cobalt complex is greater than iron, and then nickel. Okay. The binding constant value also we establish the binding constant value. And PARP cleavage experiment establish the apoptotic nature. If it is not apoptotic, then we can say this one as good anti-cancer drug. So next, it is another some ligand. Objective of this work, you see, synthesis of these metal complexes from this ligand, using this ligand. All these are new. And then we applied to investigate their anti-cancer efficacy upon U93 cell, human cancer cell. This work actually published in this new journal of chemistry. Next, synthesis of another this kind of ligand by condensation of these two units, and then we prepare. This is a zinc and some, it is not cadmium or some nickel, okay? So we give C3A, C3B this way. So what is the conclusion from this work? That thiazole pyrazine derived ligand, all we get mononuclear compound, all these compounds show effective anti-tumor activity. Both C3A and C3C follows necropsis pathway of cell death, and where free ligand, these follows the approach. That means these guys, these elements are better than these two. The apparent binding constant suggests the strong intercalating mode of the with the DNA. So further study is going on also. So you see the next another compound, this ligand, we prepare these three compound, 4A, 4B, and 4C. This is another chemistry part, so we are not telling about this. So conclusion from this work, you see, the acetonitrile insertion is happened in the reaction, and you see it is metal perchlorate. If perchlorate present, then only amide formation is happened. That means CH3CO group is included in the main frame of the structure. So all these compounds are structurally characterized. The amidine complexes show higher toxicity effect than the free ligand and non-amidine complex. So here we show that amidine complex are good, are better than the non-amidic complexes. Conclusion from this is continued. You see, this is the order in the forming the composite of ctDNA and copper-2 complex. So on the basis of the result, it is evident that pyridine thiazole based copper-2 amidine complexes can be regarded as a bright candidate for further evolution as chemotherapeutic agent. So another, this work actually 5A, L5A is cobalt complex. It actually published in journal Molecular Structure. This is the structure of this compound. This is cobalt complex. Outline of the structure. Conclusion from this work, this new ligand that is mononuclear cobalt-2 complex spectable resonance in vitro cytotoxicity effect against human histiocytic lymphoma U93 cell with IC50 value. There is one IC50 value. Those who are biology people, they can understand the IC50 value. It's very low, you see. Low means good. So the apoptosis mode of cell death for both ligand and the complex. Here you see metal free and metal added are confirmed their Casper study, apoptosis mode. That means they are good. Both compounds do not show any cytotoxicity against normal blood cell, peripheral blood monocytic cell. So these are the conclusion. Conclusion is continued this way. You see, intercalated, moderate intercalator. So mode of interaction with DNA. So is moderate intercalator. Simultaneously, we can also say group binder. Actually, the drug, when interacts with DNA, there is a different kind of mechanism. So maybe group binder, maybe intercalator. So in this compound is actually the moderate intercalator, we cannot say distinctly as a group binder based on my experimental results. Okay. The cell death and DNA binding efficacy of the ligand L5A, HL5A, slightly higher than the complex, cobalt complex. So as I said earlier, that metal-free compound may be sometime show higher effect than metal-added compound. So here is the example you see in the case of L5A and cobalt complex of this. So another ligand, it is published in little earlier, 2017, polyhedron, and also Journal of Chemical Information and Modeling in 2022, it's a very good journal. So here we synthesize this one, and cobalt, manganese and nickel complex, here you see. This is the structure of this compound. This is cobalt, manganese and nickel, the structure outline of this compound. The conclusion from this HL5B and its metal derivative, that is pyridine containing thiazole derivative, are the class of organic compounds showing excellent biological activity. So you see pyridine, in my former case it was pyrazole, in another case it was thiazole. So we choose this way, different kind of heteronuclear, heterocyclic compound. So this thiazolyl pyridinium bromide molecule, that is this one, the ligand is in its salt form, bromide salt form, with some complex cobalt 3, manganese, nickel. Thus, all these actually compounds show stronger anti-cancer activity against human monocytic cell. So, L5 and C5 exhibit better activity with IC50 value we see very less, 0.39, and this value for complex. So this is this for ligand and this for complex. So here metal-free heterocyclic compound shows better activity, anti-cancer activity. The conclusion is going on in this patient side also. So we are able to do some docking study to corroborate the experimental results. So all these actually supported each other. So pyridinium thiazole compounds and their metal derivatives emerges as potential anti-tumor activity and need to be explored in better understanding for biological application. So you see, my work ends at that point. After that we can go. That means clinical, some experiment and others. That is our ability and that is our weakness also. From the small laboratory, we can't go beyond that. And here you see one Dalton transaction publication. So we use A to D, that means 5 some ligands and with metal cobalt 2 complex. The title is evaluation of the anti-cancer activity with various ligand substitution in cobalt 2,3, picolyl phenolate. You see here we use picolyl phenolate derivative, synthesis, characterization, DFT, DNA cleavage and molecular docking study. We do everything A to Z, whatever we can do in my small laboratory. And this is the journal. So anyway, these are not so important. All these are journal heading. So I would like to thanks for your patience. So what is the take-home message, please, student? You see, pyridine thiazole ligands and its corresponding complex compounds show better activity than the pyrazine thiazole ligand against human monocytic cell. Okay, that means heterocyclic compound, more or less, they will interact with DNA and they can they can show the anti-cancer activity against human cancer cell. So thank you very much for your kind patient. Listen me. This is my group. This is Dr. Bera, Pradip Bera. He is also here in the first session. Here is another guys, Gopinath. All these are actually, this is Abhimanyu and this is Gopinath. And this is Abhishek Iyer from CDFD, biological work. He did all this biological work. Anyway, thanks to again for listening this.
Any queries from the audience side regarding these topics? I think no. Thank you, sir, for your nice presentation. I think this research work will open a new window in the medical science. So once again, thank you for your nice presentation. And now I am requesting Professor Dr. Raman Singh to hand over the certificate of appreciation to Professor Dr. Pulokesh Bera.
Hey, just one second. Hey, Robin, একটা ছবি তুলে স্ন্যাপ দেখি।
এই তানিশা Then certificate of appreciation is given to Ms. Tanisha Mukherjee for her oral presentation. Now for oral presentation, who are willing to deliver it on online mode, if anybody is present, please response. HSE-2024. If anybody is present in the online mode, please response. For oral presentation, if anybody is present for oral presentation, serial number HSE-2024, who want to deliver it on online mode, please response. Anybody is ready for oral presentation? HSE-221-2240. Those who are want to present oral presentation through online mode. Nobody is responding. So if anybody is ready, please wait. Now the invited lectures is presented by Professor Dr. R.N. Jana, Department of Chemical Engineering, Haldia Institute of Technology.
কোন ফোল্ডার? পিটি।
So now invited lectures is presented by Professor Dr. R.N. Jana, Department of Chemical Engineering, Haldia Institute of Technology.
Good afternoon. So after post lunch, we are starting plenary lecture here. Myself, Dr. Rabindranath Jana, Associate Professor, Department of Chemical Engineering, Haldia Institute of Technology. I would like to discuss on the topic nanomaterial for fire extinguishing agent. As this institute is related with the course providing fire and safety, so I think the student will be more benefited through the discussion of this topic. As you know, the fire is a chemical reaction where that a huge amount of heat is being generated, and that heat may be devastating to the everything. Heat may burn everything. Okay, so even it may burn metal also. The different type of the metal, whatever we like to that, it may sustain say some temperature, but after say 2200 or 300 degrees centigrade, that heat, that is iron, it will also melt. Okay, so nobody will exist before the fire. But again, fire is essential. So from the early time, the invention of fire gives us the civilization, modern civilization. In the earlier days, the people living in the forest, in the jungle, they used to eat raw material, the food, the raw flesh of the another animal. They are hunting the animals in the forest, and without any cooking, they used to eat it. But with the invention of that fire, by the burning, that rubbing of the two stones, the fire incident happened, and by the primitive man, they used that fire for cooking sometime, and also the warming themselves, as they are living in the forest, in the cold countries, even in the cold areas even. Nowadays, without fire, we cannot live. As we see, without mobile phone, we cannot live. The same way, the fire is have a huge that application. As we see in cold countries, the fire, they are getting the room heating system by electrically or by gas heating even. Okay, and even the fire, with the fire we have some metallurgy, different type of engineering material are being developed, even different type of polymer, whatever we like to get to reshape, we need also heat. Plastic, whatever the petrochemical product we are getting, nowadays we are using so many of plastics in our daily life. The plastic it is getting the shape as per our requirement with the application of heat. Okay, so heat is very essential, and we cannot avoid it. We require it, and as you know, in our daily life, we also cook our food with the help of heat. Okay, but as I mentioned, say before that heat or say fire, nobody can resist. Okay, again we have to fight. We have to get some prevention so that we can use the heat or fire in proper ways. Okay, if there is some the out of control heat, how to control it? We have to know that the situation. We have to know the technology. Then only we can properly use the heat, and we can proceed, go ahead with our civilization. In near future, maybe nowadays, whatever we are using, coal burning electricity, the electricity are being generated mainly fossil fuel. We can avoid it. Maybe solar cell we can use. Okay. Again, the energy is required for our say modern life. We cannot avoid without any energy. We cannot do anything without any energy. But proper utilization, proper control, we should have in our hand. Otherwise, it may damage our property. It may damage our life, everything. So, the control of fire, it is very important, and as a fire safety officer or your supervisor, the student should know they are trying to learning day by day. Our faculty members, they are enriched with experience from the industries. Also, they are past experience, different incidents, and they are delivering the lectures with live examples. And the students are being motivated so that they are learning the things, they are doing some practical work, they are practicing themselves, they are making a good person to fight against the fire. As I also used to take some classes to the students, and I would like to teach them on this topic, and I would like to motivate them that this firefighting job as a fireman, it's a noble job, okay, similar to the doctor, equivalent to the MBBS doctor. As the doctor, he is curing the patient, and he is saving a life. Same way, that fireman, he is also saving the life of the injured person or the person who is entrapped in a fire. So there should be PPR accordingly, mental strength should be there, physical strength should be there, so that the injured person, how to rescue them from the high-rise building, or say from the different industries, from the hazard areas, different toxic chemical if it is there, flammable gases if it is there, how to handle them in proper way, that type of training we are providing here. Okay? So with this small introduction, I would like to say a few words, the latest trend, whatever we are having in this area, firefighting area. As you know, there are the different types of fire. I think the student may know about it, A, B, C, D, and K, sometimes also saying K, A, B, C, D, I think is known to everybody. So depending on the different types of fire, what are the available fire extinguishing media, they also know. Say just for example, say A-type fire means a solid fire, wood, paper, pulps. That fire, if it is happening, we can use only water. Okay, water, just it's plenty of water. If we put on the fire, it will extinguish. But how it will extinguish, if you know the mechanism, that will be very interesting. Okay, so the fire, as I mentioned earlier, say it is a chemical reaction, and that chemical reaction, it requires three elements, mainly oxygen, fuel, and heat, or say temperature sometimes you can say. So it's the fire triangle. In the fire triangle, there are the three elements. If we remove any one element, then the incident of fire will not be there. So the element, removing of element means their concentration also. It is not like that if all these three elements are present at any concentration, then there will be fire incident. It is not like that. So if they are having the sufficient concentration of oxygen, sufficient concentration of fuel, and also sufficient amount of heat, then only fire incidents will take place. So this idea is very important to control the fire. So the fire triangle means with the proper amount of the oxygen, or the fuel, or temperature that is required to catch fire any substance. So the LPG, whatever it is, if we know they are the boiling point or say flash point, so definitely we should store that chemical below that temperature. Then never there will be no fire. Never there will be fire. Okay. So same way, if the oxygen level it is reduced, the certain value, then only there will be no fire incidents. So we have the control measures. If we know that the important parameters about the fire, then we may control the fire immediately or easily. Now, in the research area, so many of the materials, fire extinguishing medium, it is used. Say for B or C type, that fire extinguisher, as you know, there are different types of materials, mostly we call it DCP, dye-chemical powder. I think you people know that the full form of DCP, that is dye-chemical powder, but what is the chemical composition of the powder? Mostly they are sodium bicarbonate, ammonium bicarbonate, okay, calcium bicarbonate, like that, okay, and sometimes nitrate also it is used, but mostly sodium bicarbonate or calcium bicarbonate they are used. So how to extinguish with this DCP? If you know that, then it will be very interesting thing that DCP, there is mainly, if you think about say sodium bicarbonate, if we heat it, then it will generate carbon dioxide easily. We cannot use sodium carbonate, okay? It requires high temperature to dissociate. So sodium bicarbonate dissociate at a lower temperature, so at around 110-20 degrees centigrade. So we prefer to use sodium bicarbonate. Okay, same way that research, so many research work is going on, and we are using the benefit of the output from the research work. And nowadays, though earlier we used say brominated, the compound, halon compound, but it is now prevented since it is having some toxicity, health hazard issues are there. So we are not using nowadays halon type the chemicals. Okay, clean agent we are using nowadays. So that introduction about that whatever we have discussed, the fire extinguishing mechanism, we can go through. This is the schematic diagram. So many of nanomaterials is used for the fire extinguishing, and now so many of research work is going on in this area. As the nanomaterial, as you know, the size of the material, it is within 100 nanometer. Nanometer means 1 into 10 to the power minus 9 meter. If the diameter or say or size, length, whatever it is, within 100 nanometer, then we call that material as nanomaterials. Okay, and if the size is small, definitely per mass of the material, it will have huge surface area. And for the fire triangle, as I discussed, say there is if the oxygen supply, if we cut it, okay, if we cut it by overlapping that nanomaterials, which is impermeable of that oxygen to the fire, to the fuel, okay, so then definitely we can extinguish the fire. And use of the nanomaterial, it is beneficial in sense that with a small amount of nanomaterial, we can cover a large surface area. That is the advantage of nanomaterials. And also definitely there is some functionality so that it will absorb some oxygen if it is within the fuel even. Okay, so say in that way we can extinguish the fire effectively. There are so many of nanomaterials. We'll discuss maybe say carbon nanotubes, okay, fluorine C60, or say polysiloxane, that is POS, or say different type of aluminum oxide, zinc oxide, fluorine. So many of nanometals still now is available. So for the mechanism, we can say that that is starvation. Okay, fire extinguishing mechanism, that is starvation, means if we cut the fuel supply, then definitely there will be the extinguishing of fire. The fire will extinguish after some time if there is no supply of fuel. Okay. Next one is the cooling. Using the water, most preferable the extinguishing medium, it is water. It is easily available, and I mean low cost, or you can say very cheap product. Everywhere it is available. So that if we pour the water on the fire, definitely it will cool down the temperature of the reaction. So as for the reaction, it is required certain temperature. Definitely if it is lower than the temperature required, definitely the fire will extinguish. So that's the cooling mechanism. And smoothing is the formation of a insulant layer. After the formation, after the burning of that material, they will form a char on the fire, on that residue whatever will be left, so that it will cut the supply of oxygen. Definitely in that way, there is no supply of oxygen, definitely fire will extinguish after some time. Then chemical reaction inhibition, some chemicals are inhibitors are available. It will absorb oxygen if it is there is a fire oxygen, the reaction is taking place. Intermittent means there is if we make a barrier, okay, or some different curtains. If there is a fire incident, if we using the barrier that we can cut the oxygen supply, definitely then there is also the fire will this way. And physical barrier, there are different types of fire door or protective walls. If it is there, then in that way the cut of supply of oxygen or different fuel, if it is possible, that will extinguish the fire. So need of the advanced fire extinguishing medium, as you know, say a traditional whatever the material we are using till now, most of the cases that their purity is questionable. Now whatever the commercial grade we are getting, their efficiency is not up to the mark. So day by day the development is required, day by day development is coming up. Purity, if you use the pure component, definitely the cost will increase, and so that people for their business to get more profit, mostly whatever the sodium carbonate, sodium bicarbonate it is being mentioned, the purity is very less. Okay, so in that case definitely the efficiency will be very less. So at the with the low product cost or the material cost, how to make more efficiency, that is our research area. I think our newer future will try to develop such material that will be more efficient. Dry chemical agents are effective against a range of fire classes, but leave residues and that complicate cleanup and harmful to the environment. Whatever the fire extinguishing media we have seen in our lab experiment also, we have taken some trail in the ground area and we make some arrangements of catching of fire with the wood or say different racks, whatever it is, with the petrol and diesel. We put fire and we try to extinguish the fire to demonstrate how to extinguish fire, and we generally use CO2 and most of the cases we use say DCP. So after applying the DCP, that powder, the student may realize that powder whatever is remaining, the disposal of powder is very difficult. Okay, it will affect the aquatic body, and so whatever the material nowadays is available, we have to think about that environmental the effect. Okay, so that's why whatever the material is required, I mean nowadays we were expecting that material is not available till now. So new materials are to be introduced. Promise of nanotechnology, as I mentioned, say nanometal is having higher surface area per unit mass of the material, so it will cover a large surface area, and if there is a fire incident, so it will cover that the fire area with that material, and it will cut the supply of oxygen. Okay, so that's why it is called smoothering. In that way we can extinguish fire. Nanometal with structures at the nanoscale, typically 1 to 100 nanometer, exhibits unique physical and chemical properties. Okay. Increased surface area, enhanced reactivity, improved thermal stability, which can be harnessed to create innovative fire extinguishing media. So these are the advantages of the different nanometals nowadays available, and we are very much aware that nanometal nowadays being used in every areas. There is no areas is fine, I mean without any nanomaterials. Okay, nanomaterials are not a new material actually. It is used in the ancient time, but it was not so popular at that time. But the people nowadays is find that it has so many of important properties, and they are trying to utilize that properties. So nanotechnology based agents are not only more effective at extinguishing fire, but also safer and more environmentally friendly. Okay. So nowadays actually research is going on. It is being, I mean, it will be applied in the fire extinguishing media. Nanoparticle can be engineered to enhance the thermal resistance of the material, reducing flammability and to catalyze the breakdown of flammable gases, thereby preventing the fire propagation. Okay. So that's why we need nanotechnology, nanomaterial for this area. Current research work, as I mentioned, some research work is going on also. So current research work like that. So ferrocene, some report is there, say in reference 1, as I mentioned, ferrocene, silver or copper, manganese, that type of metal nanoparticles are being used as a fire extinguishing media. Carbon-based nanometal, that is graphene, carbon nanotubes, fluorine, they are also being used. We have the reference, and polymer nanocomposite, they are being used also as a fire extinguishing media. Hybrid nanomaterials, or say calcium hydroxide nanoparticles, nanoclays, aluminum nanoparticle or zirconium oxide, they are being also used. Yes, there is some challenges till now. Whatever the nanometal, we are suggesting that it will be useful, it will be more efficient, but it has also some drawback. So what are the challenges? It is also nanometal is having some toxicity, and so also some environmental impact. As I mentioned, the powder, whatever the DCP powder we are disposing of, it is having some toxicity. Also nanometal, though we are using very less amount compared to the traditional metal, whatever we are using nowadays, but again it is having some toxicity. And since the particle size is very low, that airborne particle, the nanomaterial, airborne nanomaterial, they will also affect our lungs or say respiratory system. So that is under question whether we will use the nanomaterial for fire extinguishing media in this in this area or not. Regulatory framework is there, as I mentioned, say we cannot use without the toxicity measurement. Okay, we cannot use after some survey or say review work. Scalability and cost, yes, till now the production of nanometal is very costly. So for this type of application, it is very difficult, not so cost effective till now. But in high hazard area where the plant is having very costly equipments, or that say maybe in other areas the installation cost is very high, or say the different type of traditional the material we cannot use. In that case, we can use also nanometal. If the space is very small, in the car even, okay, nowadays in the car you can see portable fire extinguishers. So in that fire extinguisher, mostly there is a CO2 type, okay. But if we use some that acid type, that is not suitable. But if we use say nanoparticle size, that size will be just similar to inhaler. We people just nowadays we have some asthma, we generally use inhaler. Okay, similar type of nano extinguisher will be there, so that if there is a fire incident during the driving in car, we can immediately extinguish the fire by just spraying. Okay, so say mosquito or say different type of cockroaches, we have red heat is there. So in similar type of that extinguisher may be there, may be developed in near future with the nanomaterials. We can efficiently extinguish the fire. Okay, as you know, say with the fire, if we allow say 2 minutes, the reaction will be double. Okay, it will spread double. So immediately within say 2 minutes, if we are not able to extinguish the fire, the scenario will be more dangerous. So long-term stability is also required. So what we conclude, the development of nanometal for fire extinguishing agent marks a transformative step in fire extinguishing technology, offering solutions that are more efficient, effective and environmentally responsible than traditional materials. So nanometals having high surface area, thermal stability, tunable reactivity that enable rapid heat dissipation, oxygen isolation and combustion interruptions. Despite of impressive progress, challenges remain, particularly in managing the environmental and health impacts of certain nanopowders, which requires careful formulations to prevent the fire incidents, to toxicity. Future research is going on, and I hope in near future the nanomaterial will be used for this area, and we will be able to develop some fire extinguisher which is more efficient, and we can mitigate the damage in near future. With this, I would like to conclude. Thank you. If any question, I will be happy to answer.
Any question from the audience side regarding these topics? Especially those who are students, it is your subject, your topics. So please raise any questions or any queries. Because you are reading this type of subject or this type of topics in your syllabus. So
okay, I think yes, please. Nowadays it is not used. As I mentioned, research is going on. After the clearance from the toxicity and all these things, the environmental impact is there. So in near future it will be useful. Okay, it is under research work. Yes, please. Yes,
any queries? Any queries, please?
I think students have listened earlier also this type of the discussion. If there are any question, we will share in after some time. Okay.
Thank you, Professor Dr. Jana.
Water means nanometer scale, actually scale 1 into 10 to the power 9 meter means 1 nanometer. 1 nanometer means 1 into 10 to the power minus 9 meter. 10 to the power minus 9, very small size. This is the size, means a nanometer means one size, length.
So thank you, Professor Dr. Jana, for your nice presentation. I think these topics will be very helpful to the students. Now I am requesting Professor Dr. Singh to hand over the certificate of appreciation to Professor Dr. Jana. So for oral presentation, anybody is present in the online mode from the serial number 221 to 240. If anybody is present on online mode to present the paper, please respond. Anybody is present who is willing to deliver oral presentation from serial number 221 to 240, please respond. So we are giving a few minutes. Nobody is responding. Yes, someone is present. Professor, Doctor, someone is present. Yes, Professor Dr. Prasad T.L. Gupta is present on online mode. Sir, you are ready for your presentation? Please respond. Yes, he is telling something. Sir, I think you are telling something. Your reply is not coming here. So we are trying to connect to you. Professor Dr. Prasad T.L. Gupta, ex-DAE and technical consultant, Bhabha Atomic Research Center, Trombay, Mumbai.
It is invited talk, no? Can you hear me? Hello?
Sir, we are trying to communicate with you.
Yeah, but am I audible?
Please stay online, sir. Stay online, sir. Stay online, sir. Sir, we are trying to communicate with you. Please stay online. Please stay online.
Yeah. Can you hear me? 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 You hear me?
Sir, please stay online. Please stay online. Please stay online. Please stay online.
Hello, can you hear me? Can you hear me? Stay on. 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 Hear me? Stay on.
তোমারই দেখেছি 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 দেখেছি
Professor Dr. Gupta, please stay online. We are trying to communicate with you.
আপন 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 ওই কপলে দেখে বলে দেখে বলে দেখে বলে দেখে বলে দেখে বলে দেখে বলে দেখে বলে
প্রাণে যদি গানের রেশরা এই পথ
Achha, Professor Dr. Prasad T.L. Gupta, you please start. Yes, sir. Yes, sir. Yes, sir. Yes, please continue. Which one? Your PPT is visible and your audio is also coming. We are listening your audio. Please continue. Which one? Sir, please repeat. Sir, it is a part of invited talk. Okay. Once again, I am introducing you. Now, the invited talk is presented by Professor Dr. Prasad T.L. Gupta, ex-DAE and technical consultant, Bhabha Atomic Research Center, Trombay, Mumbai. Sir, please continue. Sir, sorry for interruption. Please change your PPT. Your slide is not changing, sir. Not changing. The first page means opening page is visible now. If it is not possible, please continue, sir. Sir, please continue. Now it has changed. Yes, it is moving. Okay, sir, no problem. Please continue. Yes, both are visible. PPT is visible and audio is also coming.